So floating point numbers. I said I was going to mention it in the last tutorial I did because they're a nightmare. Whenever you start adding numbers together that have decimal points, you're entering a whole new universe, and things get really weird. When you add simple numbers together, really weird stuff starts to happen. And the first time you see it and you're looking at it on the console, it's just the most bizarre thing you've ever seen, and you just want to kind of throw your hands up and say, what is this stuff? Let me show you, and then you'll see exactly what I mean, and then I'll show you how to fix it and kind of sidestep the entire issue altogether. So it's actually a moot point anyway, but it's really interesting stuff, okay? Okay, so let's have a look at some number madness in JavaScript. Before I actually get into this, I'm criticizing JavaScript on this, but really it's not a JavaScript thing, it's an issue with mathematics in general. Because, if you had one of the packet sandwiches where you have like two sandwiches inside it, you can give one to your friend and you have the other one, so basically you have half each. That works, but then when you try and cut a cake in half and give one half to your friend and the other half to your friend, is it exactly a half? Not really, is it? You don't know exactly how many molecules are on each side of this. And it gets even worse if you start dividing things by 3. If you cut a cake into thirds, if you could exactly cut that into thirds, what would happen is you'd pick up one piece of the cake and you'd be pulling it up off the plate, and it would have this trailing, diminishing to infinity recursion in there, all the way down to, well, forever, ever, basically. And we as human beings have issues with infinity and trying to visualize things that are infinite. So I think it's only reasonable to presume when you're working with numbers and you're trying to conceptualize very large numbers or very small numbers, that you have to have some level of cutoff for your own sanity. And that's what floating point arithmetic's all about. When you're representing things in JavaScript, the basic stuff's dead easy. If you look at this, right, if I just did 1 plus 3, we know what these values are, and it works really well. But things start to break down when you have numbers that are very large, because the computer can't really understand it very well. So let's just have a look at some of the functions that we built into number. We have maximum. We actually have maximum safe integers in here and minimum safe integers. So let's just have a look at this. I'm just going to set this to myInt. Okay, and let's have a look at it. So this is quite a large number, and when you start working with this, you should be okay. But once you start going above it, things start to break down. And unless you know about it, you'll be doing this kind of stuff. Let me just give you an example. So say you're adding 1 to it. Seems to work. Seems to not work so well. Yeah. You can see how things are starting to break down a little bit. Not acting quite how you would imagine. And things start to go all wrong. So what I'm suggesting is, if you're working with large numbers, make sure that they're safe. This is the first thing you would do. So there is function available here to check whether this is a safe integer or not, and that's what I would always check. So you check my integer, make sure it's safe. You should be good to go with that. But if you start adding things to it, even though you might originally get a decent result, as in per this. It's still not safe. And you just got to be really careful. You think it's working, but actually it's not really working so well. It's not doing exactly what you'd be planning, So you just have to be a little careful with very large numbers. And let's have a look at very small numbers. And this, well, actually, not even small numbers, just dealing with decimal points. And this is back to that cake analogy of having a representation of decimal points is very difficult. Whenever you're thinking of, say, 10 cents in the dollar, really what you're doing is you're taking a fraction of that. That's what that decimal is really doing. It's saying it's a tenth of it, and sometimes this becomes hard to visualize. Let me show you in code. Okay, so if we had 1 plus 3, not a problem. What happens when we do, say you're doing mathematics with a shopping cart, and you say, okay, something's 11 cents, and then you add, I don't know, 0.24 cents to this. So here we go, and you get exactly what you would imagine. So here you are working with your shopping cart. Everything is working, to all intents and purposes, the way you'd expect. right? Yeah, so you think, what's the problem? Why is we even talking about this? Absolutely no problem at all. And then weird stuff starts to happen. And, you know, when you first see this, you're thinking, what is this? I mean, how do you deal with this stuff? You know? And that's when things get a little tricky. So first of all, let's cut to this too long, don't read stuff. Don't use decimal points when you're working with things like shopping carts. The best solution that I can recommend is, instead of trying to deal with this rattlesnake, cross over the road and just deal with cents. So I would be dealing with something like 11 cents plus 29 cents is exactly what I'm expecting it to be. If you want to represent that in fixed variable decimal points, you can do that. Well, there's a couple of ways to do this. You know, normally you do dots and do things like toString and stuff. With numbers, you can do double dot. I don't like using that, so I'm not going to show you. I'm not going to show you that. You should just be doing this kind of stuff, and you can say toString, for example, and then just see what that represents as. And it's 40 toString. If you want to represent that in precision points, you can do obviously to precision. To precision. I'll probably spell this wrong. Let's just do 12. Okay, and this is actually 1, 2, 3, all the way to 12 precision points. I'm recommending fixed. Okay, so if we do 2 fixed, and this is as many points as you want. So when you're working with cents, what I would do is something like this. You have to be careful with this thing called precedence, by the way, in maths. If you're not that familiar with it, if you remember it from school days. If you don't do this correctly, what will happen is this dividing will take precedence, and you end up with not what you want. So you have to be careful when you're adding everything together. I mean, I know this is basic stuff you learn at school, but you know, I don't remember half the stuff I learned at school. So this is how I do it. I would work in pricing cents as integers, so they're reliable. And then when I come to print this in US dollars, I could be doing this kind of stuff. Whoops. Yeah, and that would be my price tag on my page, something like that. So that's what I would recommend, because you start doing this stuff, things will act weird. It might not give you what you want. So rather than fully understand how that we have issues with converting binary numbers to decimal when we reach very, very small limits of precision and worrying about all this really gnarly mathematics, I would just understand that you have to do your own form of truncation and just cross the road completely. As I said, don't deal with this rattlesnake and all these very large numbers, very small numbers. Just try and cross over and do this kind of stuff in your shopping carts. For those of you who aren't just building little shopping carts and doing basic JavaScript and building massive number crunching systems, well, I would just say you probably shouldn't be using JavaScript in the first place. All right, bye.